Okay, for what we have in the case of the first problem in finding the partial fraction decomposition, we have the ratio whereupon 5 is all over x times the quantity of x minus 1. And for partial fraction decomposition, we're looking at breaking up 5 over x times quantity of x minus 1 into separate fractions where we have the denominator factors to be separated. So we have for the partial fraction decomposition setup, so we have a over x plus b over x minus 1, and we're looking at solving for a and looking at what we have here. If I multiply the equation by both x and x minus 1, and of course, x times the quantity of x minus 1 is going to be the least common denominator. So we have, for the left-hand side of the equation, both x and x minus 1 cancel. So this will leave us with 5. As for a over x will cancel out, and we're going to have a times the quantity of x minus 1. As for the variable b, okay, b is originally situated over x minus 1, and multiplying by the least common denominator, we have x minus 1 will cancel out, and we have b multiplied by x. And so we have a couple of unknowns with a and b, and from x minus 1 and x, I have as many zeros that I can apply. Say if I want to solve for a first and get the b out, so I can set the x factor x to 0. And if I set x equal to 0, what is going to happen is that we're going to have 5 is equal to a times the quantity of 0 minus 1 plus b times 0. And of course, b times 0 is 0, so this will go out. And we have that 5 is equal to a times negative 1. So we're going to have that 5 is equal to negative a, and changing the sign at both ends. So we're going to have that negative 5 is equal to a, and so it's going to follow that we have for a the value of negative 5. Okay, so you have a at negative 5. Now, in looking at what we have in the case of b, okay, so I negated b upon setting x to 0, but now I'm going to negate a as I set x equal to 1. So we're going to have, in this particular setup, setting x to 1. So we have, in setting up, so we're going to have 5 is equal to a times the quantity of 1 minus 1 plus b times 1. And we're going to have that 5 is equal to a times 0 plus b. And taking what we have now, okay, so we have looking at multiplying.
You from AT&T DirecTV to let you know that your account is qualified for 50% off. In order to obtain the discount, kindly call us back on the number you see on your caller ID. Thank you and have a great day.
Okay, so we have that 5 is equal to b. And so we're going to have that 5 is going to be the value for b. Okay, so we can write that b is equal to 5. So with a at negative 5 and b at 5. So just putting back, so the partial fraction decomposition is going to be negative 5 over x plus 5 over x minus 1. And just taking what we have in the setup. So we have negative 5 over x. And we have plus 5 over x minus 1. And checking the result, and the answer is correct. Okay, for what we have in the second problem, we have negative 6 all over x squared minus 16. And looking at the partial fraction decomposition, now we have with x squared minus 16, okay, we have a difference of squares. And the factors we're going to have with x plus and x minus 4. And taking what we have in the setup. So we've got, in decomposing, okay, so we have with the denominator x plus 4. If I let this be the first denominator, we'll have the first numerator at a. And we have for the next ratio, we have b over x minus 4. And if I multiply what I have in the equation by both x plus and x minus 4, we're going to have for the combined ratio, so we have left-hand side becomes negative 6x. For a, okay, x plus 4 cancels, but we will have the distribution of a over the quantity of x minus 4. And for b, it's going to be the other way around. X minus 4 will cancel, but we're going to have b to be distributed over x plus 4. And now we have two unknowns with a and b, but we have as many zeros that we can apply. So if I set x plus 4 to 0, so as to negate b and go ahead and solve for a. Okay, so if x plus 4 is 0, x is going to be negative 4. And for the setup, we're going to have negative 6 times negative 4 is equal to a times the quantity of negative 4 minus 4. And we have plus b times the quantity of negative 4 plus 4. Negative 6 times negative 4 is positive 24. And we have a times negative 8. And we have plus b times 0, which will be 0. So b is going to go out completely. And we have that 24 is equal to negative 8a. And we have a division by negative 8. Okay, it's going to follow that for a, this will be at negative 3. So we're going to have negative 3 over x plus 4 in the first ratio. And now negating a, we can now set x to 4. And so we have negative 6 times 4 is equal to a times the quantity of 4 minus 4 plus b all over 4 plus 4. Negative 6 times 4. Okay, so this will be at negative 24. And this time we have a times 0. So a goes out completely. And we have plus b times 8. So we have negative 24 is equal to 8b. And we have with division by 8. B also turns out to be negative 3. Okay, so we're going to have in the partial fraction decomposition. Okay, so just checking what we have now. We're going to have negative 3 over x plus 4. And with b at negative 3, we can say we have minus 3 over x minus 4. And checking, and the result is correct. Okay, we have in the third item, we're looking at finding the partial fraction decomposition of this particular ratio, whereupon we have 3x squared minus 3x plus 1 is all over x cubed plus 2x squared plus x. So if I look at factoring what is in the denominator, okay, now we have the greatest common factor is going to be at x. So you have x times the quantity, and we have of x squared plus 2x plus 1. So this comes down to 3x squared minus 3x plus 1. And this will be all over x times, and we have x plus 1 times x plus 1. And we have 3x squared minus 3x plus 1. And this is going to be, again, all over x times. And we have with x plus 1 times itself. If I write this in compact fashion, we're going to have x plus 1 quantity squared. Now, and looking at what we have in the setup, looking at setting the stage for partial fraction decomposition. All right, so we're going to have a linear factor with x and a repeating linear factor with the square of x plus 1, or with x plus 1. So we're going to have a over x. Now with x plus 1 raised to the second, I'm going to have one factor expressed in the denominator as x plus 1. And with the repeats, I'm going to have x plus 1 squared. So I'm going to take, for repeating linear factors, I'm going to start out with the first order of that factor and then go up to the degree to which it is expressed. Like if I had x plus 1 to the third, I'll have like a constant over x plus 1 plus another constant over the square of x plus 1 plus the constant over the cube of x plus 1. But here we have with the square of x plus 1, and we have b over x plus 1 plus c all over the square of x plus 1. Now if I look at multiplying by the least common denominator, so this is going to be x times x plus 1 to the second. And if I take what I have in the ratio, okay, so if I multiply by all of x and the square of x plus 1, okay, what's going to happen here is that for x and x plus 1 squared, okay, left-hand side of the equation, okay, will become 3x squared minus 3x plus 1 for what I have on the right. Now for a, x is going to cancel out, but we're still going to have a to be distributed over the square of x plus 1. And as for b, okay, now in b, now we have one order of x plus 1 is going to cancel out. But we're going to have x plus 1 with a degree remaining as well as x. So you have b times x times the quantity of x plus 1. And as for c over the square of x plus 1, we have the square of x plus 1 to cancel, and x left over, so we have c times x. All right, now we have three unknowns and a couple of zeros that we can apply. Okay, so let's say that if I look at solving for a first, so if I set x to 0, so I'm going to have 3 times 0 squared minus 3 times 0 plus 1 is equal to 8 times, okay, the square of 0 plus 1. We have b times 0 plus 1 plus c times 0. Again, we have the b and the c terms to cancel out. And for what I have on the left, okay, so we have 1, and a times the square of 1 is going to be a times 1. And so it's going to follow that a is equal to 1. Now for the other factor, we have an x at x plus 1. I can set x plus 1 to 0 by setting x equal to negative 1. And taking what we have here, so I have 3 times the square of negative 1 minus 3 times negative 1, followed by the addition of 1. And just filling in. And so for what we have at this particular stage, okay, so you have b times negative 1 times quantity of negative 1 plus 1 plus c times negative 1. And again, negative 1 plus 1 is going to be 0, so a is going to go out. Negative 1 plus 1 is also 0, so b is going to go out. Now we have for 3 times the square of negative 1, so we have 3 times 1. Negative 3 times negative 1 becomes positive 3. And we have plus 1. C times negative 1 becomes negative c. And here we have 3 plus 3 plus 1 is equal to negative c. So you got 7 is equal to negative c. And if I change the signs at both ends, then we have that negative 7 is equal to c. Or in this case, we have c equal to negative 7. All right. So just looking at what we have at this stage, now we have solutions for A and C. And we can solve for B. And I can choose an arbitrary value for x. And I tell you what, we'll go with x equal to 1. And if I plug in 1 for x, so I'm going to have 3 times the square of 1 minus 3 times 1 plus 1, and have equal to 8 times 1 plus 1 to the second, and we have plus b times 1 times 1 plus 1, and a half plus c times 1. Okay, now we have a recorded at 1, c at negative 7. And we got 3 times the square of 1, so I'm going to have 3 times 1. Negative 3 times 1 is negative 3, and I have plus 1. Again, a is at 1. So I got 1 times the square of 2. And I got b times 1 times 2. And c, again, we have at negative 7. Again, 3 times 1 is 3, minus 3. This will go out, and we got 1. And we got 2 squared is 4. And we got plus 2b minus 7. 3 minus 3 is 0, plus 1 is 1. 4 minus 7 is going to be negative 3. I have plus 2b. And if I add 3 to both sides, we're going to have that 4 is equal to 2b. And we have with division by 2, we had that 2 is equal to b, so we're going to have that b is equal to 2. So just looking at what we have here, so we have a at 1, b at 2, and c at negative 7. So for the partial fraction decomposition, so we have 1 over x plus 2 over x plus 1 minus 7 over the square of x plus 1 and so looking at what we have in the process, so we have 1 over x, and you have plus 2 over so you got 2 over x plus 1, and we're going to have minus 7 over what's going to be x plus 1 raised to the second power. And we have upon checking, and the result is correct. Okay, for what we have in the next ratio, we have 2x plus 22 all over x minus 1 times the quantity of x squared plus 7. And if I write this in terms of partial fraction decomposition, now the general setup, we're going to have a over x minus 1. Now for x squared plus 7, this is what is referred to as a quadratic factor. That is a factor of second order, like in the case of the sum of squares, which cannot be factored. And for quadratic factors, I want to maintain a 1 degree difference between what is in the denominator expression and what will be in the corresponding numerator. And for what I'm going to have here, now if you notice in the denominator, this is going to be second order in x. And if I maintain a 1 degree difference in x, now the numerator is going to have to consist of a first order term in x. And we'll refer to this as bx. And I want to close out the numerator expression with a constant. So we're not going to have just b or just bx, but bx plus c. And so this is the general partial fraction decomposition setup. Now, if I multiply the whole equation, okay, by the least common denominator, which would be x minus 1, and the quantity of x squared plus 7, what's going to happen here is that the left-hand side of the equation becomes 2x plus 22. As for a, x minus 1 will cancel, and we're going to have this to be multiplied over the quantity of x squared plus 7. As for bx, now bx was over x squared plus 7, but it's going to be multiplied by the quantity of x minus 1. And guess what? The same thing is going to happen for c. X squared plus 7 cancels. And like b times x, c is going to be distributed over x minus 1. Now we have 3 unknowns with a, b, and c, but we have a couple of real zeros that we can apply, namely from x and x minus 1. And I tell you what, if I go ahead and solve for a, I will be able to negate b and c if I set x minus 1 equal to 0, and that will be through setting x equal to 1. So if I set x to 1, so I have 2 times 1 plus 22 is equal to a times the quantity of 1 squared plus 7. Again, we have b times 1 times the quantity of 1 minus 1 plus c times the quantity of 1 minus 1. Again, 1 minus 1 is 0, so b and c are going to go out. Now 2 times 2, or 2 times 1 is 2 plus 22. That is going to make 2 plus 22. 1 squared is 1 plus 7 is 8. So I have that 24 is equal to 8a. And we have a division by 8. Okay, we're going to have that a is equal to 3. All right, so we have a at 3. Now, the other 0 I can apply will come from the standalone monomial factor x. And if I set this equal to 0, so I'm going to have 2 times 0 plus 22. Again, we have equal to a times the quantity of 0 squared plus 7 plus b times 0 minus 1 plus c times the quantity of 0 minus 1. Again, the b term is going to go out. And we have 2 times 0 is 0 plus 22 is 22. You have a times 7, and we have with a at 3. So we have 7 times 3, or 3 times 7. And we have minus c. So we have that 22 is equal to 21 minus c. And upon taking 21 away from both sides, we have that 1 is equal to negative c. And changing the signs at both ends, okay, we're going to have that c is equal to negative 1. And in taking what we have now, so we were able to utilize the zeros from x and x minus 1. Now, I don't have any more real zeros that I can use, so I'll just choose a number arbitrarily, okay, to set the stage and solve for b. And I tell you what, we'll go with, say, x equal to 2. And if I go this route, so you have 2 times 2 plus 22 is equal to 8 times the quantity of 2 squared plus 7. Again, adopting what I have from the setup. And bx, again, we have b times 2. And you have times x minus 1, which would be 2 minus 1. And we have plus c times the quantity of 2 minus 1. 2 times 2 is 4. 4 plus 22 becomes 26. Again, we have a is at 3. 2 squared is 4 plus 7 is 11. And we got 2 times 2 minus 1 is going to be 2 times 1, which is 2 times b. So we have 2b. And we have plus, what's going to be c? So you're going to have minus 1 at the end. So we're going to have 26 is equal to 33 plus 2b minus 1. So we're going to have 26 is equal to 32 plus 2b. And if I take 32 away from both sides, 26 minus 32 is negative 6. Negative 6 is equal to 2b. And we have with division by 2, it's going to follow that b is equal to negative 3. So we have a at positive 3, b at negative 3, and c at negative 1. So for the expression that results, we're going to have 3 over x minus 1. And we can say we have plus, and would be at negative 3. So you have negative 3x. C at negative 1, so you have plus negative 3x minus 1 over x squared plus 7. And just taking what we have here, so you have 3 over x minus 1, and we have plus, and we have in the ratio, so we have negative 3x minus 1 all over x squared plus 7, and checking the result, and it is also correct.